Dear students, welcome to our class on effect of temperature profiles on eddies. Effect of temperature profiles on eddies. Very interesting. I defined the temperature. Please subscribe to my channel Agrometeorology Farmers and Rural Development. There I have defined in several ways temperature, potential temperature, whatnot, even heat also. Now, for your academic interest, before we go into temperature profile, temperature is defined as measure of speed per molecule of all the molecules of the body, whereas the heat is the energy arising from random motion of all the molecules of the body. Temperature units are degrees centigrade, degrees Fahrenheit. Now potential temperature, degrees Kelvin. So 273.15. Okay. Now if you take the potential temperature, here the temperature is potential with the height. There are usually three temperature profiles as far as above the ground is concerned. Below the ground we are going to discuss in a separate class. Above the ground, the first situation is the neutral, the second situation is the unstable, the third situation is the stable situation. Usually neutral situation occurs during an overcast days. How and why? See, I told you the basics of introductory agrometeorology climate change that the rate of change of temperature with the rate of change of pressure is known as lapse rate. Okay. Now, dry adiabatic lapse rate 10 degrees centigrade per kilometer. Wet adiabatic lapse rate is 5 degrees centigrade per kilometer. Now, average adiabatic lapse rate is 6.5 degrees centigrade per kilometer. Now, see, if you take the eddies in the atmosphere, eddies, potential temperature with height, under the neutral condition, this occurs on overcast days. Now, the eddies will be small, slightly bigger. They retain the shape like a ring-like structure. Now, under the unstable situations, what is an unstable situation? Where the ground is warmer than the air during the daytime in general. Okay, what happens here? It is oblong in shape. Okay, the eddies are oblong in shape under the unstable or lapse rate conditions. Now, under the stable conditions, it is called, we call it as the inversion of temperature. In the troposphere, the temperature shall decrease as the height increases, but sometimes, and particularly during the night time, in tropical areas, what happens is inversion takes place. The ground temperature is less, air temperature is more. Under those situations, the eddies will have shapes like this. Okay, shapes like this. Now, so to sum it up, okay, potential temperature, height, unstable, neutral and stable. Just for your academic interest, 2-3 important points I would like to tell. Turbulence is generated by friction. In the previous class we discussed frictional velocity and mixing lag. There, turbulence is generated by friction. The density of air is affected by temperature. Therefore, the vertical temperature gradients influence the movement of air in the form of dash. This bit will come eddies, in the form of eddies. Now, so there are so many differences between the eddies and the ordinary molecules I told, but for your academic interest I will say eddies are generated during the turbulence. Okay, gas molecules, they have separate characteristics. Eddies have separate characteristics. So these two are entirely different. Now, so I just would like to sum it up like this. Number one, thermal gradients influence vertical transport and affect the shape of the wind profile, so that it cannot be described with logarithmic wind profile. Temperature profiles have to be described in a separate way. This is what I would like to share with you. Once again, to sum it up, under the neutral conditions, the neutral conditions, when they exist during the overcast days. Neutral, just the eddies retain the shape. Under the unstable condition, particularly during the daytime, the surface temperature is more, air temperature is less. Unstable, the surface temperature is less and the air temperature is more. It is what we call as the inversion, that is the stable condition during the night time. Of course, this is the summing it up. So, concluding, last one line. Wind profiles over the bare ground, we discussed. Wind profiles, how temperature profiles affect the eddies, we discussed. In other words, temperature profiles. Thank you very much. May God bless you.